So we're talking about functions in the previous lecture. So what happened is there are different problems that fit in one template. So we have a quantity, and that quantity somehow affects the other quantity. Okay. So as let's suppose we have this height over here, which I have written over here. We have this height, and we have age. So somehow they are related to each other. So these two things are related to each other. Again, the temperature somehow is related to the date. So if you even see these graphs over here, so let's suppose if you have a small kid, so in that fashion, so he'll have some height, or he or she will have some height. Slowly, when the kid gets older, accordingly, the height also increases. So there is some pattern that you can see. So many of the problems fit into this template. One quantity somehow affects some other quantity. Okay, height affects age, or age affects rather height, and similarly, date has some effect to the temperature. It might not be causation. I'll again tell you. So this might not be causation, because we are not learning about what causes what. Rather, we are thinking, we are learning in the paradigm what has a relation with some other things. यहाँ पे हम relation की बात कर रहे हैं, हम लोग cause की बात नहीं कर रहे हैं कि किस चीज से क्या चीज हो रही है. That's a different subject in itself कि causation पढ़ना. So here we are more or less related with relation. What is related with what? कौन सी चीज किस चीज के साथ related है? So I said there is somewhat some relation between age and height. Okay, and there is some relation between this date and temperature. And if you see that, that's how even the seasons came up. हमने पूरे ईयर को 4 सीजन में इसलिए डिवाइड किया, बिकॉज समहाउ वी सॉ अ पैटर्न, वी सॉ अ रिकरिंग पैटर्न, एक साइक्लिक पैटर्न दिख रहा था हमें. So somehow this date has some relation with the temperature. And similarly, if you have to mail an object, अगर हम courier भेज रहे किसी जगह, तो then weight, according to the weight we have to pay the things. हम लोग weight के हिसाब से ही चीज़ों को pay करते हैं. So the cost of this mailing has something to do with the weight. They have some relation. All of these problems, many of other problems are there. Okay, area of circle has something to do with its radius. Similarly, the number of bacteria in a culture is somehow function of time. If you just keep one bacteria over in a pot or something, and you just observe these, and they'll somehow like get divided, and there will be the biological phenomena will happen, और वो grow कर जाएंगे वहाँ पे. And somehow time does have an effect with these. बहुत सारी प्रॉब्लम्स ऐसी तुम्हें मिलेगी जहां पे एक क्वांटिटी हैज सम रिलेशन विद अदर. दैट्स व्हाई मैथमेटिशियंस दे केम अप विद द कांसेप्ट ऑफ फंक्शंस. Okay, so basically what function is just a rule. If you see it here, it's a rule that describes how one quantity depends on the other quantity. Okay, then we sort of had in the previous lecture, if you see that, we put some more constraints on the function. We said it's not just now the function. The thing is that we'll put constraints. One input should have a unique output. Okay, I made some diagram like this. I said if this is, let's suppose, function input. Can you please mute? I'm getting some echo. Okay, and think function as a machine. इसको ऐसे सोचो कि एक मशीन है हमारे पास. Okay, now it is getting some input, और ये एक output दे रहा है हमें वापस. Okay, input it gets into the machine, and machine does some processing, और वहाँ पे हमें output मिल रहा है. But this machine, I talked about determinism also. This machine should be somewhat deterministic. So let's suppose you are giving 1, it should give 2. It should, in the second time when you again give 1, it should not give you 3 or 4. It should again give you the 2 back. Okay, that's the thing. And then we saw how do we write these relations, what's called domain, range, and all of these things were discussed by that time. Now today, what I'll do is I'll first tell you what are the different ways of the representation of these functions. Okay, so there are 4 ways usually. So you might even read books and you will see like even in the mathematics books there are mostly equations, but you also will read these sort of functions written verbally. Okay, so these are the 4 ways where you can see it. Either you can see it verbally, or you can see it in the algebraic formulation, or you can see it visually, or you can see it numerically. Okay, now we'll take everything one by one. So how can we see these functions? Do not lose into the fact that we are basically just talking about a tool. A function is basically कि एक tool है. Don't get in the realm कि हम लोग क्या कर रहे हैं. We are dealing with some abstract mathematical details. We have a problem. The template is some quantity defects on other. There is some relation. Okay, कुछ relation है उन चीज़ों में. अब उन चीज़ों को मुझे दिखाना है. Now I have to think about the relations. अब वो कैसे मैं दिखाऊंगा? Now there are 4 ways to do that. The first way is that I'll sort of verbally write it. अगर तो मैं उस चीज़ को verbally लिख रहा हूँ. So how I can do that? Okay, so let's suppose एक verbal way में हम लोग कैसे लिखेंगे इसको verbally. So verbal way of representation. सब लोगों को भी पता है this like people are from India, it's burning hot in Bangalore. Usually it is not the case. तो लेकिन इस साल क्या है, बहुत temperature है. Now we know that in different countries people measure temperature by degree Celsius. ओके, सब कॉन्टिनेंट में यूजुअली डिग्री सेल्सियस में हम लोग मेजर करते हैं, एंड इन सम अदर कंट्रीज पीपल मेजर इट इन डिग्री फॉरेनहाइट, एंड देयर इज अ फॉर्मुलेशन हाउ यू कैन कैलकुलेट इट, हाउ यू कैन कन्वर्ट दिस. ओके, so the first way is how I can write it verbally. So I can say it like this: to convert from Celsius to Fahrenheit, multiply the Celsius temperature by 9 by 5 and then add 32. Okay, this is the verbal representation of a function basically. So what I'll write is, I'll write to convert degree Celsius into degree Fahrenheit, multiply degree Fahrenheit by 9 by 5 and add 32. Okay, before algebra was invented, people used to communicate like this. Okay, when we don't have the operations and things like that, when we were not having these variables and stuff, people used to communicate. Even if you see books, like really classical books, you will see these verbose statements written. Okay, that's one of the ways. Okay, there is nothing wrong in this way, but we humans, we somehow developed the visual intuition. It's better that we speak very less words, and somehow we should get our point through. Okay, the verbal way is good, it's good, but the problem is we cannot be more sort of creative, or we cannot do much with this. Okay, and there will be people who will be probably understand, they'll be really good in verbal way, but the thing is we want to have a succinct representation, we want to have something so that we can manipulate it, we can see it with that. Okay, so usually I say mathematics is like poetry, the equations have meaning. So if there is an equation written on the on paper, or it's written on it's written anywhere, so if you are not able to translate it verbally, then there is some problem. So that is the understanding that you should have. If there is an equation, you should sort of write it verbally. What is this equation telling me? Okay, so mathematics is poetry. So for students, so you should not think mathematics as something weird, you should think it as poetry. So poetry में क्या होता है, हम लोग बहुत बड़ी बात कुछ छोटे बहुत कम शब्द में बोल देते हैं. That's what mathematics is. Now you saw this verbose statement. कितना verbose है ये? Okay. So now if I have to tell the same statement in some mathematical way, equation way में लिखेंगे. That's what the second way said. So I said the first thing is verbally. You will see things written verbally everywhere. If you see, now you will have to have a lens. So my job here is to install these lenses onto you now. So now if you read a newspaper, there you will see some. So this stock price rose because this thing happened. Okay. Now you see this. There is actually a function written there, but now it has been said verbally to you. Now your brain should work like this. Oh, there is this function, that there is something written onto this newspaper. So can I represent it in function? So that is what is called as mathematical thinking. Okay, I want you guys to have mathematical thinking. Three thinkings I want you guys to have. The first thing is mathematical thinking. The second thing I want you guys to have is algorithmic thinking. Okay, and last I'll say you should have computational thinking. So I'm clear. Am I clear with this mathematical thinking, at least for now? So what I'm saying by mathematics is that if you see something, you should somehow think it mathematically now. Okay, I had a thorough discussion with you people, I think in session 0. Like we had pre-session 0 actually. So in that I had a discussion with what this mathematics gives you. Something, there is some representation in your brain of things. Okay, then to bring into that into mathematical world, you should see the things and you should try to bring those into mathematical world, because mathematics, it gives you tools to manipulate that thing now. So similarly, now you have this verbose equation. I want to get into this into the mathematical world. So what I'll write is, to convert this degree Celsius into Fahrenheit, I'll say, let's suppose degree Celsius is represented by some x or some c. Okay, now c I'll call it a variable. Okay, now what I have written here, to convert degree Celsius into Fahrenheit, multiply degree Fahrenheit, or probably I have written it should be degree Celsius. It should be degree Celsius by 9 by 5. Okay, degree Celsius by 9 by 5 and add 32. So degree Celsius multiplied by 9 by 5 plus 32. This gives you Fahrenheit. Many of you, it is really easy formulation to understand. Okay. So if you now see this, both are these two things. The first thing, the verbose way, and this equation. So let's write this equation. This equation and this verbal statement. Both of them are equivalent. They convey the same information to you. But here, if you see now, you have introduced some things. You have introduced these symbols. We introduced symbols, and second thing, you have introduced some operations also. Basically, symbol also has an operation. Okay, because you know ABCDs, that's why I have written. If somebody is from Urdu background or Arabic background, we could have write, let's suppose some alif is equal some degree Celsius means bay, multiply will be written something like tick, something like this. Okay, then 5 by 9, let's suppose we'll write it like this, 5, and divide we'll probably write it like wiggly line, by 9 we'll probably write it like this, plus we'll write it like by some symbol like this. I'm bringing up the symbols. I want you to get the details that you could have discovered it yourself. And then I could have read 32, something like this, if I'm right. Okay. So this basically is the same thing that we have written over here, because now you are comfortable in these English letters. So that's the reason I wrote it like this. Okay. You should think the equations to be like this. Okay. This equation again is telling me the same thing, but here I'll have to explicitly tell you this aleph and this bay are variables. So these things are variables. Okay, and this over here, this tick over here means I am multiplying, or multiplication has a meaning. Okay, and this symbol over here which I have used means addition. Okay, and this over here means 32. So now I'm just truncating out these details. So what I'm saying is mathematics basically is way above the language. It is sort of agnostic towards the language. It doesn't care which language you speak. It is just the game of symbols. How many of you understood this? Mathematics is nothing but a game of symbols. I'll pause here for 30 seconds. If you have questions, I'll also take them. I don't see any questions. Okay, let's go. Let's get back. So mathematics, what I said is nothing but a game of symbols, and mathematics is poetry. So now we are in a verbal domain, and people now we communicate verbally. And after that, now we just had one more layer of abstraction. We brought the things into mathematical world where we have these symbols and we operate onto these symbols. Language does not give you this, because language, if you have a statement, if you have a sentence, you cannot operate onto that sentence. Probably you'll have to bring it in the mathematical realm. So why am I telling you this? Why is it necessary? Because if you see these transformers, chat GPT, probably everybody has taste of that. You might have been writing mails, or you might have been doing something with chat GPT, rephrasing the things. How is it doing it basically? So what is it taking? It's taking this verbal representation, whatever verbally you are saying. It's taking it in the mathematical realm. It is taking it to some high dimension space, representing it in numbers. Now it's really easy to manipulate numbers, because for the past 3-4 centuries we have been developing these mathematics. Okay, that's what becomes easy. That's what I want to say. I wanted to say that verbally, that's a good way. I have no objection speaking verbally, but the problem is it restricts you somehow. Then what we did is we came up with this algebra, and now we'll represent it algebraically, where we have these symbols and we have these operations. And now there's again one more thing, visually. Okay, and probably we'll have a thorough discussion on this also. And then one thing is numerical. We'll have all discussion with these things also. So how many of you understood sort of this connection between the verbal way and the mathematical way? So mathematics basically is just a language. It's nothing. It is explaining some reality. Okay, I think most of you understood this. Okay, going now back. Now we have these mathematical ways. Now we are not really good at sort of memorizing these things. So I wrote, let's suppose degree Celsius multiplied by 9 by 5 plus 32 is equal to degree Fahrenheit. Okay. So we are not good at memorizing these things. So what are we good at actually? So by evolutionary biology, evolution, and you see that our visual cortex have been developed. Okay. So I don't want to go into this because I am no way the expert in that visual cortex and things. But what I'm saying is that by the evolution, or the way we interact with the environment, visually we got somehow evolved really nice. Okay, and visually we can, if we somehow see the things visually, we try to remember them more, and we try to infer things from them. That's why we can also represent these things by graphs. So what are graphs now? Graphs are nothing but just a visual representation. Okay, whatever words tell you, whatever these equations tell you, again graphs tell you the same thing. Okay, and that's sometimes there's a quote that a single picture is worth 1,000 words or something. Okay, so if you have a picture and it explains a lot of things, again it depends on the receiver, basically whoever is seeing the picture. So you have a picture over here. Okay, now you see the art. So first the visually, you have people who are really good at literature. Now from that we got poetry. Now I said we have a counterpart in mathematics. Mathematics itself is a poetry. We said that mathematics is poetry. Literature, so this is basically that literature study. Now we have this. There are people who paint very well, and painting also is art. Okay, if somebody makes that boat, he makes ocean or something, people sort of understand different meanings. They derive different meanings from paintings. Now again in the mathematics, we have a counterpart. We have graphs. Graphs are like paintings. Okay, so graphs are like paintings. That's why I'm really bad at spelling. Why? Because I try to think mathematically. I hate to write. You'll see me making terrible mistakes in writing. Okay, that's why I'm in love with maths. Come, likho. Really good, nice, enjoy. Okay, so what I'm saying is graphs are like painting. So what I said is these algebraic that representations, they are like poetry. Now in poetry still you will have to write things. Now if you want to see things visually, so what you will do, you will have these graphs. Okay, I'm trying to explain you the four representations that you usually encounter with the functions. Okay, the first representation was verbal representation. The second representation is the mathematical representation, and the third representation is the graphical representation. The graphical representation is basically like paintings. If there are people who will love to see paintings because they'll extract meaning from that, and that's why people are different. Some people like these, they like the verbal statements. Probably they are humanities major, arts major, and they love to see these things and have poetry or stuff like that. So similarly, some people love numbers and these small variables. They like succinct representation, and some people have really love for this visual things. So they love to see some paintings. So mathematics gives alternate to everything. So you have equations, that's counterpart to what poetry is, and you have these graphs, that's the counterpart of paintings. Now we can represent these functions with the with this graphs as well. So for the graphs, you have to have a background, which again I'll not assume, because here probably people will get pissed off because again I'll be teaching very basics. Now how to show this graph? Now you should have a frame to paint on. अब हमारे पास एक फ्रेम होना चाहिए पेंटिंग करने के लिए, उसके बाद ही पेंटिंग कर सकते हैं. फॉर दैट मैथमेटिशियंस हैव टू थिंक कि अब ये फ्रेम जो है, ये ग्राफ तो हम पेंटिंग तो बनाएंगे हम लोग, पर ये फ्रेम कहाँ से लाएं? वी शुड हैव अ नेम फॉर इट. ओके, सो देन दे ब्रॉट दिस कार्टेशियन प्लेन. So they bought this Cartesian plane. They saw, oh, this is my frame. So हमारे पास ये frame है, हम इस पे paint करेंगे. Okay, we'll have a, so Cartesian plane basically is nothing. If you have this 2D Cartesian plane, again I won't, it'll again take me hours to discuss on what dimensions are, but I'll assume here some things. So if I draw a line vertically like this, and if I draw one line like horizontally like this, somehow if I have a 2D sheet, I'll divide this sheet into 4 parts. They are called as quadrants. Just some lingo. You're just learning about what quadrants are. Okay, so what is the need of Cartesian plane? Because now I want to paint, I want to have a graph. For that purpose I must have something to paint on, some canvas I should have. Okay, let's suppose sheet of paper, we have painters को हम लोग sheet of paper देंगे और brush देंगे, and now mathematicians, they also should have something. So for them we developed this Cartesian plane. They themselves developed this Cartesian. They said, okay, I'll do one thing, so I'll make this Cartesian plane. Why introduce only this? Because we'll be mostly dealing with functions in one variable. So we'll say, so this is the one variable. Let's suppose if we have a function y is equal x square. Okay, so y will be represented on this. Okay, and x square will be represented on this. So this axis over here, if I again go to mathematics, this will be my domain, and this will be my range. Okay, and this is my canvas. Okay, I'll call it a canvas, I'll call it a frame or something. You will see I have a high tendency of inventing names. Okay, I'll invent names here and there, and you probably won't find them in books, but it's all right. I just want you to understand the things. Now I have to draw a graph. So for the graph drawing, or for the painting, I have to have a canvas. So for that canvas, I came up with the Cartesian plane. I think everybody is clear with the Cartesian plane. So we'll have this independent variable onto this, or we'll have this dependent variable onto this. So now I'll graph the function. So what is the good benefit of the graphs? Okay, so what I'll do is this graph should tell me something visually. I want to see the relation. Okay, what relations can be there? So let's suppose height increased with age. I should infer this thing. Let's suppose if you see this, if I just write some equation onto this, so you should have that mathematical lens. So if I wrote this equation, degree Fahrenheit, degree Celsius into 9/5 plus 32. If I have that lens, you will be somehow telling me that 100 degree Celsius will be somehow greater than if you convert into Fahrenheit, because this is getting multiplied by some bigger number than 1, and then we are adding some 32 onto this. So if you have a number, let's suppose 100 on degree Celsius, so multiplying it by 9/5 will make it greater, and again if I add plus 32, it will make it again the greater. So the relation between this is, so degree Fahrenheit, so if you have a number 100 in degree Celsius, so in degree Fahrenheit when you convert it, you will get a number higher than that. So there is some proportionality, there is some relation. When you increase one thing, other thing also gets increased. Okay, there is a relation. So it's really easy to see it visually. Okay, I had to tell so many things in order to tell this. Okay, degree Fahrenheit, let's suppose 100 degree centigrade is 212 degree Fahrenheit. So if I write 101 degree Celsius, it will be greater than 212 degree Fahrenheit. So you will see that there is some relationship that's always increasing in here. Okay, it will not decrease, and sometimes you will see that a relationship decreasing also. So somewhere, let's suppose we have a value of x and we have value of y. So if you feed in x, so you will get, let's suppose, 100, and corresponding to that you got 212. So if you have now 101, you got some 214, let's suppose. Now you can see that with the increase in x, we got increase in y also. Okay, there is some relationship. If one thing increases, other thing also increases. Okay, that's in mathematical terms we call it, they are directly proportional to each other. So if one thing increases, other thing also increases. So this you have to have a mathematical lens in order to understand, because it's a huge equation, let's suppose. There you'll have to figure out, okay, so if I have to mathematically prove degree Fahrenheit is equal to degree Celsius plus 9 by 5, okay, plus 32, I'll have to tell you, okay, this degree Celsius, this is greater than 1. Okay, so I'll write, so this actually gets multiplied with greater than 1. So multiplied by greater than 1 plus 32. So I can already see that the number will be increasing. Some sort of mathematical details I'll have to see. Now this graph makes it easy. If I just draw a function, you can clearly see. So some functions will be like this. So if I just wrote this x square, okay, and I have to get value of y. If I write 2, so it'll give me 4. If I write 4, it'll give me 16. You can see that I increase the value of x, y also gets increased. So there is a relation between them. So x gets increased, y gets increased. And if you just draw the graph, you will see x square something like this for positive axis. This graph clearly shows that if you increase x, so by increase of x, I mean you are going on into this right direction. But that is increase in x. So parallelly you will see that this y also gets increased. Okay, you can clearly see it visually from this. So that's why graphs are sometimes important. They'll tell you the change, how change happens, like how fast the change is there. Okay, we are heading towards the calculus basically. Okay, most of the things that you will see, they'll be appealing once they are written in the graphical manner. Okay, now how to draw these graphs? Everybody of you knows how to draw the graphs. So if you have, we will just form the table. So if you have this Cartesian plane now, again we have this plane, we have this canvas. Okay, this origin, we call this as origin. So here we assume this is as 0, 0 point. So the value of x and the value of y is 0, 0 right here. This is again assumption. Okay, we are working on assumption again. So there are something called as affine transformations. I don't want to get into that, but understand that we have to fix some origin over here, because anything that is measured against a reference. Okay, when you make a measurement, so that measurement is made against a reference. हम लोग ऐसे ही कुछ भी measure नहीं करेंगे. So हम लोगों का कोई reference होना चाहिए measurement के लिए. So that's why we have put this in place. We have said कि हम लोग origin रखते हैं, that will be at 0, 0. What is the meaning of this 0, 0? So this basically is saying that whatever this line is, okay, it has 0 value onto this, and whatever this line is, it again has 0 value onto this. So now I have to, what I said is, so certain things are easy to see in the graph. So as I made this x square for only positive axis, x square. So now if you see this, if I increase x, increasing x means going in the right direction. Okay, decreasing x means going in the left direction. So this is my x and this is my y. So what is my function? So my function is y is equal to x square. That's my function. So here if you see that if I increase x, you can clearly see the y also. Let's suppose for this point. Okay, so the value of y is somewhere around here. Okay, if I increase x, I'll go to this point. So if I now see, you'll go to here and you see the increase, direct increase. So how to now draw these graphs? So there are really easy ways. So you take this equation, you just take some independent values for this x and you will get the values corresponding to y. So you will draw a table like this, x square and y. If you give 1, this will be 1 square, this will be 2. If you give 2, this will be 4. If you give, let's suppose 3, this will be 9. Okay, this is the way of representing a function. I came to the fourth type of representation. The first representation was verbal representation. The second representation was the representation by using the algebra, by using the equations and by using these symbols and these variables and these operations. The third representation was graphs. Okay, now how to understand this graph? So how is this basically this graph made? So if you want to make the graph, you just have a tabular representation. You have the points, what is the relation? Now if you want to draw this 1, 2, so this will probably be 1 and this actually is 1 square is 1, sorry. So this will be 1, so this will be again 1. So this is 2, this will be 4. Now if I say something like this, this is let's suppose 3, so this over here will be 9. So these points on this line, if you see, so these points lie on this curve. Okay, so they are being represented by this data. Now you saw there are 4 representations again, coming back to that thing: verbal representation, algebraic representation, and then we have graphical representation, and we have tabular representation. So now I install a lens onto you. So whenever you see a table, you make sure that you write in the function. You make sure that, oh, there is some function involved. Can I write in the mathematics? If you see a graph, okay, and you should be clear that there is some function going on. People here are from finance, and usually financial people see a lot of graphs. So they'll see, okay, the market is going like this market is going sideways, suddenly something will happen. Okay, then you can see that something impacted this and the value of the function it was now ever decreasing. Now stock market crashed or something. Suddenly sometimes you can see this, something is going like this and suddenly you will see a trend over this. So here you can see clearly that here we have a function, increase in function. So graphs give you a lot of value, and some people are really good at tables, so they just see the tables and they'll find the relation. Okay, so how many of you understood the four types of things that are basically functions? What is not a function now? Thank you, Sagir Abbas, for correcting this mistake, x square y 1 and 1. Any questions? Mahmood, I'm waiting for the question here.
This bacha problem, Abhi.
Okay, so how to make these functions now? If you want to make these functions now, we have to really use the online tool. So there is a tool called as Desmos calculator. Okay, I'd like to show you that because many of the times you will see this. So you will see that if you sort of have this calculator at hand, if you just give it a function, it will somehow draw a function, and then you will get to know if the function is increasing, decreasing, whatever there is. Okay, now let's go to the calculator to show you how to draw their functions. Okay, again I'm teaching to undergrads, I'm not teaching to postgrads, I'm not teaching to PhDs. That's why undergrad people, you should know these sort of tools. Okay, coming up with the Chrome, I think I'll just open. If you now want to draw a graph, so what you have to write is, so again this is the Cartesian plane. If you see that this is a Cartesian plane, there are two axes, x-axis and y-axis. So this over here is my x-axis and this over here is my y-axis. So these are my two axes over here. So now if I want to draw this function, y is equal to x square. So what I'll do is, so there is some bar here, I'll just write y is equal to x square. Okay, so this is the function that y is equal to x square. Okay, so this is the function, this is the parabola. If I have to draw linear functions, let's suppose I'll draw a function y is equal to 3x plus 4. Okay, I will draw the degree Celsius and degree Fahrenheit. So degree Celsius was equal to degree Fahrenheit was equal to degree Celsius multiplied by 9 by 5 plus 32. So if I want to draw this, let's call this y and let's call this x. Okay, so this is y is equal to x multiplied by 5 divided by 9. So multiplied by 5 by 9 and then plus 32. Okay, if this function went out of the, I'll just remove this 32. So you see the linear relationship I want to get in. This is the linear line. Okay, so now you see this graph and this linear increasing. Here it was increasing quadratically like this. This was our function of x square, and this over here is a linear function. Okay, it's of format what's called as y is equal to mx plus c. We'll get to know what this m is, what this slope is, what this intercept is. But I thought like you guys are now clear how to make these functions, how to draw these functions. You should not even make the tables nowadays. Just go to Desmos calculator. Now you can also have complex functions. Let's suppose I have a function like this. Sin x is basically a function. So sin x plus 3 cos x. Okay, this function is like this plus some x. You can see this complex function I am making. It's difficult to draw it because you have to calculate everything by hand. It's not difficult it's not difficult though, but it is tiring. Some sort of, it'll take some work, give the value to x, then compute and then compute y. So it's better to utilize these tools. Okay, everybody clear with the tool?
Yes, but we can only see the blocks.
Okay, everybody clear with these tools? Okay. So sometimes what you will see functions which you cannot directly write like this. Let's say y is equal to some m x plus c or something like this, or y is equal to x square plus 4 x or something like this. Okay, sometimes they have some steps. So one thing will happen if certain condition is met, and other thing will happen if some other condition is met. So there we have to somehow define them as steps. Okay, they are called as piecewise functions. Piecewise functions. Okay, this might be the answer to the question. Decreasing, increasing, if there is the abrupt jump to these things. So how to represent that? So here you are seeing that when you have this, let's suppose x square, y is equal to x square, there was a smooth function like this. Okay, it was not making like smooth function like then suddenly going like that, and it was the function was not defined in between and something like that. So if there is something like this where the function is defined on a certain thing and suddenly it is not defined for certain things, and after that you will have to define it in a function. So we define it as in a piecewise function. Let's suppose we have this y, so we can divide it into folders. Okay, so this y takes value, let's suppose 3x when x is greater than 5. Okay, and otherwise it takes value x square when the value of x is less than equal to 5. You now see that there are two folders to it. So function behaves in a certain way when there is a certain value. Again, function behaves in a certain way when there is some other value. Okay, that's why these are called piecewise, because you define these functions as pieces. Okay, so now coming to the one part. So here, if you see, these are called the intervals. Okay, so what these intervals are now? So now the thing is, we have domain. So domain can be countably infinite, it can be countably finite, it can be finite also. Okay, so what we have is, now we'll define intervals. So what these intervals are, and now let's have a discussion on intervals. Okay, so if you see this, if I just make this x square graph, I'll use the reference graph. So this is my x square. So now if you see from here to here, okay, this function has particular values. So I'll call this as an interval. So from this to this is x interval. So because I consider this as my domain, this as my input. This is my domain, or this is my input, and this is my range. Okay, so now what these intervals are defined. So intervals are basically pieces of domain. So you want to see how function behaves in a particular domain, how function behaves in a particular interval. As Arsana also asked a question, in the same quadrant a function can increase or decrease. So you can see that if we somehow have a function like this, something like this. So now you can see, you just want to see for how much time or for which interval does this function is increasing. Is this function increasing? Just suppose if you take values from here, the values from here till here. So in this interval, if you see, this function is increasing. Okay, if you take interval from this, if I zoom it in, if I zoom this function in, so from here to here, this function is again increasing. So but if you see from interval here to interval here, so this interval, okay, to this interval, so this function is decreasing. Okay, that's why we define functions, because we want to get hang of this. So sometimes a function cannot be represented like that, which I said, a function cannot be sometimes represented directly with just one equation, and we have to bring in multiple equations. We bring in these piecewise things, and then we come up with these intervals. And there are different types of intervals. Okay, now there are closed intervals, open intervals, semi-closed intervals. So what are these? So sometimes what we try to do is, if I write something, this is just again a notation. So if I write my function is defined on 3, 2, or maybe 3, 5, I'll write it like this. Okay, 3, 5, and if I write it like this, so this means do not include this 3 and do not include this 5. So this will be an open interval. Just leave the last points, and we have now, if they're only integers, so this will be 3, 4 and 5. This basically means take only the 4 value. So 4 will be an interval. So this is 3, 5. This is an interval. It represents 3, 4, 5 values. But if it is written something like this with these braces, so this means this is open interval. You should not take this 3 and 5 value. You should just care about 4. If it is written like this, 3, 5, written like this, so this means closed interval. So it is graphically shown like this. That means you have to check the function on these values, 3, 4 and 5. So now there are 3 values, and semi-closed can be written like this. So this can be something like this. Okay, include this 3, do not include this 5. So 3, 5, or just leave out this 3 and include the 5. These are intervals. Why are we defining intervals? That the rationale behind that is, sometimes function behaves in a certain way, and you must define intervals. And sometimes a function is not defined on certain values also. So we say that from here to here in this interval, your function is not defined. Okay, so we'll get into that once we know how to compute the domain of a function. Okay, sometimes a function is defined for certain values, not defined for other values. Okay, and you will see that there's a discontinuity of functions, and slowly we'll lead towards discontinuity, towards differentiability and things like that. The first thing you should be clear with this is that there is a function, the things have dependency, one thing has a dependency onto the other, and we brought in the functions, and function is basically a special type of relation. Then function has a range, it has a domain. Now domain also can be broken down. Okay, in order to study these functions, we break down these domain. These broken down small things are called as intervals. Okay, there are these different types of intervals which I said. Is it clear so far? Can I move with the change? Okay.
Yeah, it's clear till now.
Okay. Now we'll see what are increasing and decreasing functions. What are increasing and decreasing functions? Slowly you will see that I'm going away from the real world detail. That's what mathematics will do. It'll start with this real world example, and slowly we'll abstract the things out. We'll keep on abstracting the things out, and then suddenly you will feel that we are so far away from the reality that this even now feels very abstract. But do not lose the picture. The picture is that we are still solving some real world problem. We still have that, but we are developing tools for that. We are developing tools to understand that thing. That's why we have to tell you what an interval is. I have to tell you what decreasing is, what an increasing function is, something like that. Okay. So what these increasing and decreasing functions are. Before that, I told you intervals, because now I'll need the concept of intervals here. So if a function is like this, it's easy for me to show a function graphically rather than writing it mathematically. Suppose a function is like this. A function is like this. Clearly, you know that this can be represented. So this can be represented by equation also. A function is something like this. Let's suppose. Let's make it a little bit like this also. Okay. So if you see these points, I'll just draw some points. So this point to this point. Okay, I'll drop a point from here to here also. Okay. So now I think that you will agree that this is an interval. So this over here is an interval. Okay, again, this thing over here is an interval. Okay. Now if you see that, if I take the value, let's suppose this is x and this is y. So usually now I'll again introduce one more notation. Now I won't write this y. So I'll write f of x. F of x basically tells me that it will take some value x and f will somehow process it and it will give me some input. Okay, this is my f of x function. So now let's call this point as a. We'll call this point b. We'll call this as c. And we'll call this as d. Okay, you know now that this a comma b is an interval. Okay, I'll include both of these points. This is a closed interval, and this c comma d again is an interval. So both of these are intervals. Okay. Now what I will do is, if I compute the value at a, can I write like this, f of a? I'll write f of a. So if I have to compute value at b, so I'll write f of b. Okay. So if I have to calculate value at c and d, I'll accordingly write f of c or f of d. So these are nothing but giving me values. So they are values of functions, values of f function, values of function which I call f at a, b, c and d. Okay. So if you see at this, if you see f of a will have some value. Let's represent that thing with some x. This is not even x. I'm again, the problem here is naming the variables. You'll feel that. Here let's call it p, let's call this q, let's call this r, let's call this s. Okay, p, q, r and s. These are basically some values. Now you will see that if I took this a and b, so this value in this function, so this will have some value over here. This value I called it as p, this value over here is q, this is correspond to this value. Again, this value over here, it's a little bit lesser. This is r and this is s. P, Q, R, S. Now there's a relation. If you see this, can you clearly see that Q is greater than P? How many of you can clearly see this? This value, this is my value P and this is my value Q. Can you clearly see that this Q value is greater than P? Okay, so if you can see this, so here you call this that in this interval you see this function is increasing. So if you take any value, let's suppose from A to B, okay, this A is the lowest value, lower value of the interval, and this is the higher value of the interval. Okay, so as the value increases in the interval, so if you take a and if you take a plus 1, if you take a plus some epsilon, okay, a is the value and epsilon is some positive quantity. So if you take this value f of a and if you take this a plus epsilon, so okay, a is less than a plus epsilon. So now you compute the function, you compute f of a, so it will give you some value. F of a plus epsilon will also give you some value. Okay, and now you can clearly see that when the function is like this, so if a is less and if f of a is also less than this, so we call this function as increasing function. The other way around is like this: if a plus epsilon is greater than f of is greater than a, so if you compute function a plus epsilon should be greater than f of a. So you see that this function is increasing because I took a and that took a plus epsilon and you saw it increased a bit. So if it keeps on increasing continuously till b, okay, this a and we had this b, so b again was greater than a in the whole interval. If the function is like this, if you take any value f of a, okay, then you take a slight higher value than a, let's call that b, and if it is greater, and we call this an increasing function because it is having that relation of directly proportional. Once you increase one thing, the function value also increases. Okay, similarly in here, if you see this, if you see this part of the function, so in this interval if you see, the same story holds. Okay, rather than the reverse story is there. This f of c is greater than f of d. but you know that this C is greater than D. This the value of, if you see this over here, let me write it with different color. So if you see this f of C, okay, and then you see this f of D, so you'll compute some value over here. So this f of D will be rather greater. So this value over here is smaller. Okay, so f of C over here is greater than this. But if you see clearly, D is greater than C. So you see the inverse relation over here. We had values A and B. So B was greater than A. What we found is, we found f of B is greater than f of A. So in such a case, we call the function increasing function. So function is increasing in the interval. But within the interval, you have to check for all the values. Okay, and graphically that you can see also. So in this interval, you can say that the function is increasing in this interval A to B. And again, now I will took point C comma D. Okay, again here D was greater than C. But when you computed the function, so f of D and f of C. Now you saw that there is this relation. So function over this interval was decreasing. So this will call as decreasing function. This over here is decreasing. And now you see the problem. The question obviously should come. Okay, how small interval should be? That is where the calculus is basically born. Okay, now you will have to take, how small will I take this epsilon? Okay, how small will it be? And then I'll say if my function is increasing, decreasing, what is the change basically? So here if you see, I was talking about change. So I was talking about nothing, but I was talking about change. So I was somehow quantifying change. अब मुझे ये चाहिए था कि चीज कितनी change हो रही है. That was the question for me. Okay, मैंने अपनी तरफ से पूरी कोशिश की. मैंने बोला okay, मैं एक बड़ा सा इंटरवल लेता हूँ A और B. But you could have told me a question, sir. क्या इसके बीच एक नंबर नहीं हो सकता क्या? Can't we have a number which is, let's suppose, some B dash? If you have this B dash number one, how can you prove that कि इस interval में increasing है, इस पूरे interval में? Okay, and then I have to, again, there are infinitely many numbers in between this A and B. So how I can prove these things, that this function is increasing all the way in this interval, and let's suppose I'm showing you line like this, but if you zoom it in, probably it is a wiggly line. It's like the line is like this. It is sometimes increasing, decreasing. Okay, that's why the calculus is born. If you have to see this change, and then we bring these infinite small values. Okay, then we'll study these things in calculus. But I just want to give you the notion why is calculus even needed. Okay, because we have to now deal with the very small quantities. We have infinity, and we have infinitely small also. That's called infinitesimal, and we'll have to deal with that. Now I think at high level you saw that what decreasing function is. If you can clearly see that there is an interval, and if within that interval a function will increase if you change the value. If independent variable, let's call that A, and dependent variable B. If dependent variable, this x is independent variable and this y is dependent variable, let's suppose. So if value A is greater than value B, the function value also accordingly increases. So in the decreasing function, it's just the reverse. So how many of you understood increasing and decreasing functions with the intervals? Okay, now what we have is, now going to what we have is called as maximum value and minimum value. Maximum and minimum values. Minimum values. There's a lot to discuss about functions. I'm just giving you the high level picture. Okay, once you'll get hang of these things, and suddenly we'll change gears. हम लोग क्या करते हैं, पूरा का पूरा mathematical abstraction में चले जाएंगे फिर. Okay, now you saw this function. A function can be like this. Okay, a function can be like this. Now you see that एक point पे ऐसा आता है function की function attains a maximum value in the local neighborhood. क्योंकि यहाँ पे ये point अगर तुम देखोगे, if you see this point, so what will happen is the function start from here, it start increasing. It took a peak value. यहाँ पे एक सबसे largest value आया, सबसे highest value यहाँ पे मिला इसको. Okay, and again it start decreasing. Within the neighborhood, if you see in this intervals, let's suppose from here to here, this is the highest value it achieved. Yes. Abbas has a question. You're on mute probably. You can ask the question.
Hello.
Yes.
Actually, I have a question that if we have a plot or we have a data x, y values, can we make the function from that?
Yes. But the thing is, if you have a tabular data, that data should be something like this. If you have, let's suppose, some x and some y over here, and you have been given some data, okay,
Yes.
and now the thing can be, let's suppose you have point 1 over here, and this there will be corresponding value 3. If again this 1 appeared, if there is this 4 value, Okay, now you saw that this is acceptable. Is this acceptable in function? Sorry, is this acceptable in function? So let's suppose this is value 1 and it gave you 3 answer. Again you have 1, this gave you 4 answer. So this breaks
For
the
example,
yes,
for
yes.
example, we have a like x is a time
Okay, x is time.
and y is the temperature,
Okay,
and we plotted it.
okay.
Is there any you have shown us some graphical representation, demos?
Yes,
Is
yes.
there any like that? If we have a picture or a data of x and y, and we can make a function from that.
Okay.
Is my question? Is
Oh,
there
okay.
any
Is there a
software or
method?
tool?
Yes, Desmos you can do that. But
Okay.
but the best thing is what you try. That's what machine learning basically is. What machine learning is. So what you will try to now do is. So that's why I'm teaching these functions. Now you will have this data. Okay, you will have this data, and you
Yes.
will see which is the best function that describes this data, and you basically are
Yes.
learning a function.
It should be fit on this.
Yeah. Basically, that function should somehow describe how this is. There will be a complex relation. So function will not be like simple like this x and y. Okay, now you will have some function. Let's suppose y is equal. It will be a non-linear function. We'll come to linearity, non-linearity again.
Yes.
There will be some non-linear function which describes this. Okay, and then probably we'll have to see different methods where we try to fit that curve. Okay, and we try to approximate. That's why in machine learning we never try to find the exact function. We try to find the approximate function. Okay, we try to approximate that because there will be
You're going
values like
to
this.
teach us that thing, no?
Huh?
In future, in upcoming class, you will teach us that thing to make a function of the if we have a
That is the
data.
whole machine learning. That's what whole machine learning. In the previous session, I told you that that's why we are introducing the functions, because in machine learning we try to learn a function. हमारे पास एक set of
Actually, in
functions
my
है.
first class, that's the reason I didn't.
Yes. In the previous, if you see our lecture 1, in that I explained what's the rationale behind explaining the functions. Because whole of the
Okay.
machine learning, if you see, whole the machine learning, deep learning is nothing but a computation of a function. We have something called as hypothesis class. It's a set of functions, and so that set of functions may be of very higher dimension, and we want to learn those functions. That's why you should be very thorough with these concepts. What a function is, what its domain is, what is the range of that function, what an interval is, decreasing function, increasing function, stuff like that. That's why
Okay.
people get lost. People, they do understand a bit of machine learning, but once they get their hands dirty, they see something, some equations written because they have lost their basics or something. So after that, they get somehow drowned in the whole area. They see I can
Okay.
code, but the problem is I cannot understand this mathematics written there. But mathematics, that's nothing. That they are just these fundamentals. You basically are telling me, will you teach us machine learning? Your question was, will you teach us machine learning? Yes, I will, because you are telling me, will you teach us how to fit this function? That's the whole machine learning.
Yes. Actually, I'm dealing with this thing, and the question arises that can I have some data right
Yes,
now? I
yes,
have a
yes.
result. I'm working on the heat wave right now,
Yes,
and there is a two-dimension data right now, date and time,
yes,
and I have a events.
yes.
Can I make them function
Right,
from that
yes.
data that I can predict?
That's what machine learning. That's what stock marketing is. You have date and you have to predict, let's say, some stock price based on what previous records are. You have time series data. The whole
Okay.
point of machine learning is you will have some data. You will feed something. You have an algorithm over here. That algorithm will give you the function basically. ये तुम्हें function देगा.
Okay.
Okay. Your question basically was, will you teach us machine learning? I said yes, I'll teach.
Thank you, sir. Continue.
Okay. Mahmood, are you here? That's why it's important to watch previous lectures also, because I cannot again go back. Because previous, I think Mahmood, I hope I have told all of these things in the previous lecture.
Yes, I'm here.
Okay, now I was talking about this maximum and minimum values. So what I said is, if you have a function, अगर मेरे पास एक function है, now you see that within an interval, अब क्या हो रहा है, एक value पे कहीं ना कहीं maximum value मिल रहा है मुझे. So I had this f of x. So I gave some values. X can take value 1, 2, 3, 4, something like this. X can take all these values. So x can take a lot of values, 1, 2, 3, 4, 5, 6. So I see that in this interval, let's suppose this is 1 and this is my value 5. So in this interval, if you see, x will somewhere take a highest value. Okay, so it will take some largest value over here. Let's call this value as suppose 3. It took this largest value. So f of 3 is greater than everything between this interval 1, 4. It is greater than everything. So we will call this value as maximum value. So maximum value in its neighborhood. In its neighborhood. And mathematically we call this as local maxima. क्योंकि ये बेचारा लोकल हीरो है. because the interval is only this much. Consider this function as whole world. अब ये मेरे पास world है. Now consider these intervals, consider them as different areas of the world. Now within a certain area or within a certain finite boundaries, you will see some maximum values. Okay, if a value is maximum in its neighborhood, okay, we call that as a local maxima. Similarly for the minima, if you see this value over here, okay, if you see this value at, let's suppose value, let's say 5.5 or 5.4 something. So add 5.5 value. So from this point till this point, we have value 5.5. So it takes the least value in the function. So this value over here, 5.5 value, this when computed gives the least value in the neighborhood. So we call this as minima, local minima. Okay, and then we have basically four things. So we have maxima, so basically maximum values, and we have minimum values. So the first thing in the maximum value is which is local in its neighborhood in a certain interval. Okay, and this is called as local minimum, and accordingly we have this local minimum and local maximum. Within the neighborhood, this value is maximum, and within the neighborhood, this value is minimum. Then there is this global. If you have the whole world now, and you take the whole function, so this is my whole function. So if you see this value over all the domain, over whole of the world, whole the values that this function is defined on. So this is the largest value. Let's call this value as some 10. So at value 10, the function takes the highest value everywhere in the domain. So this we'll call as global maximum. This is called as global maximum or global maxima. Okay, then we have this local and we have this global. Similarly for the minimum also global. Okay, if you see, probably this value is also local and this is also global maximum also. These are local minimas. These values are local minima. This is a global minima. Okay, so why am I talking about these? Because that's where we're interested in. So in some machine learning, we want to optimize things. Okay, so everything basically can be drawn as a function. So if it's even a mosquito running in the world, how random is the walk of the mosquito? But still that can be thought as some function. There is some function which can define it. Okay, so that's what stock market basically is. Stock market probably is way random. Okay, there is something called as random walk theory, but still we try to fit in a function onto that. We try to see there is a function which will define it. There will be some function which will define it. See the language. So language basically seems random. So there are these words. There is a dictionary. Let's suppose we have 10k words in a dictionary, 10,000 words, and you can put them in any order. You can put them in order, and you see this language is so complex, but still there is a pattern in the language. There's a pattern in the language. That's why ChatGPT is so good at finding the pattern. It is somehow finding the pattern in the language. It is doing nothing, just computing the higher dimensional function. Similar with the image. If you have an image, so what is an image? Image is a bunch of pixels. Image is bunch of pixels. So these pixels can take any values. Each of the pixel can take countably infinite values. But when these pixels take a certain value, then a certain image is formed. Let's suppose if it is an image of dog, so each pixel will have a certain value. When each pixel will take that value, that basically is a function. So what function basically tells you? So if I give all the possible values, what will be the output? Let's suppose this is described by a function. So function takes all the pixel values. Okay, so what you are basically computing when you are trying to see if it's a dog or a cat. So what you are doing is you are giving these pixel values to the function, and you are saying if the pixel value are these and these, so what should it be? So it'll tell you it should be dog. See the humongous amount. See how big the problem is. Each of the values over here can be any value. So basically, a pixel value can be a real number. Usually, it's a number between 0 and 255. Okay, we have 3 channels also, RGB channels. Okay, now you see that each value can be 255. If we have a small image, let's suppose we have an image of 28 cross 28 image in which we have 784 pixels. We have 784 pixels. 784 pixel, each pixel can take 255 values. I'm just talking about, let's suppose, some image which is only one channel. So it will take these RGB values. Actually, each pixel basically takes 3 values, R, G, and B. It has 3 channels. I'm just simplifying the problem. You see, these many number of values can be there. Now we have to identify कि इसमें कौन सी picture dog की है. That's nothing but basically learning a function. We're trying to learn a function. So this function now lies in how many dimensions? So ये 784 dimension में lie कर रही है. Now we have 784 variables to tinker. We have 784 input variables. हमारे पास सिर्फ अभी x था. So we had this f of x. And we are computing something. We're saying f of x is equal to x square. हमारे पास सिर्फ एक variable था and we'll compute. We're saying that if this x can take value 1, it will give f of x will be 1. If it takes 2, it will give 4. Now think that we have 784 pixels, and each the pixel can take 255 values. Okay, now for each pixel I'll have 784 inputs like this, and each input will be different. Okay, now I'll have to tell you if it's a dog or a cat. See the beauty of mathematics. We abstracted out the detail. It doesn't matter to me if it is an image, if it is a video, if it is audio, whatever it is. To me, they're just variables. To me, there are some things which take values, and after that, what I do is I'll just compute a function. So function should take that as an input and give me an output whatever I want. Okay, that's why learning this mathematics is important, and we'll see all of these, how to turn these things. Now you see this additional step being involved. Now if you have any data, so this data must be converted first, so as to fit into mathematical realm. This should be converted. Okay, so this part we call usually as like encoding. We have to encode the data in a certain way. As you have problem, let's suppose you have problem in time series, so you'll have to encode the data. So once you have encoded the data into a mathematical way, then you are doing nothing but fitting a function. You are trying to find a function. किस किस को ये चीज क्लियर हुई? How many of you can see the beauty of mathematics? Okay, now coming to this again, back to this maximum minimum. Why have I shown you this minima and maxima? Okay, sometimes you have a function. Okay, you are seeing that. Let's suppose I have a function which describes. If I let's suppose here we have, let's suppose I have money. If I invest this much money, and here this is the profit. And there will be some more criteria over there. I am just simplifying the problem, and it may somehow depend like this. Okay, something like this. So what you want to sometimes do is you want to optimize a thing. Okay, you want to either minimize or maximize a thing. That's what a function, in that you want to find this minimas or maximas. Okay, you want to, let's suppose, find this. I want to minimize the usage of something. I want to maximize my profit. In this case, you want to maximize your profit. So how much money should you invest? Because with money comes risk also. Let's suppose you are investing in stock market. You want to say, okay, how much money should I invest? So I get the profit which will be somehow optimal profit. It is not that you will get highest profit. Okay, optimal doesn't always mean highest. Optimal means that if I put this much amount of money, so chances of winning are more. Okay, so better is to put only this much. If I invest more money, so if there are more chances of losing, so I lose the money. So better, how much money should I invest so that I have the high chances of profit? So you see that this is the value of that money. There will be a function defining that. There will be a function. There will be that relation between the money and the profit. Okay, with the risk involved and everything involved, and that function will somehow look like this. And you want to find this global maxima. Okay, you want to find this global maxima, or sometimes you want to find global minima. There are problems. There is a whole field of mathematics which deals with this. That's called as optimizations. Okay, and we'll also learn that, because all these things will serve the basics. Once we go to optimizations, again it will become jagged so quickly, because mathematics have tendency to go away from the real world very quickly. You will feel that just now we're talking about height and we're talking about the weight. Just now we're talking about age and we're talking about height or something, and suddenly we are dealing with some other problem. So that's what mathematics will do, and it will suddenly change, because now mathematics does not restrict you to solve one problem only. Whatever problems fits into that template, will solve it. Doesn't matter what. That's why this machine learning, it is not just applicable to. This machine learning is basically just not applicable to computer science. It's almost applicable to everywhere where you can collect data. If you have data, we'll just apply this. You just want to compute the function. Okay, so just to summarize these things, what we have done so far. So we saw what functions are. We gave some interpretation in the lecture one. We saw what a set is, what is the domain, what is the range. In today's lecture, so what we started with, we saw representation, different types of representation. Different types of representation. And after that, we saw what intervals are. Okay, and then we saw what is an increasing function and what is a decreasing function. And after that, we saw what this minima and maxima means. Minima and maxima. So these lectures basically are intuitive. So you have to develop the intuition here. So once you develop the intuition, then all the things will talk into mathematical details now. So now I won't be using much of these verbose things. Whenever I am doing something, I'll just write something like this. F of x is equal to 3x square plus 4x plus 5. Okay, find its local maxima, find its local minima. Or tell me the domain, tell me the intervals. So now we'll speak about the mathematics. So once these things are in place, If these things are in place, and once we move on here, it should be easy. It should be clear and easy for you guys to sort of bring in the answers. And it's not big difficult, because you just see that there is some underlying phenomenon which is represented by this function. It's nothing but that. Okay, so now we are at this level of abstraction. Now these variables can be much more than this x. They can be some trigonometric functions. It can be 3 of sine x plus something, sine x plus 3 plus 4 tan x or something like that. And it can be a lot of things more than this. So, but the whole point is, if you understood these sort of things, then it will be easy for you to get in the mathematical foundation and bring up the answers, come up with some new things. So, what mathematics had given you now we'll operate on these functions. अब हमने क्या सीखा? हमने एक language सीख लिया अभी तक. हमने अभी vocabulary सीख ली बस. So, we have a vocabulary with us. So, now how to operate on this vocabulary is the question. That's what I said maths is. So mathematics में क्या होगा? You'll have a lingo. So हमारे पास एक language होगी. Now mathematics में additional tools क्या है? To manipulate that thing. To manipulate. Okay, मेरे पास दो. Let's suppose if I was living in some cave, I'll tell I have, let's suppose, 2 lions I saw, and I saw let's suppose 3 cheetahs. Okay, something like this. So now this language cannot tell me a lot of details only. I'll have an abstraction, but mathematics gives me these numbers on which I can operate. I can say this 2 plus 3 something. I have these many number of animals. Okay, these are the operations, and this is the manipulation. So now you want to manipulate the language. So now we developed vocabulary, and we now know the operations. I assume that you know plus, you know minus, you know multiplication, and you know division, because these are the operations that are valid on the functions. अगर ये चीजें नहीं पता है तो please do come prepared. ये चीजें पता होनी चाहिए, and then we'll operate on the functions. And then we have different things with the functions. So each time we'll do this. So each time we'll first develop a vocabulary, and after that we'll just learn how to operate onto that vocabulary. उस vocabulary को manipulate कैसे करेंगे? That will be the template. So I hope that you are now comfortable with the vocabulary. If you still are not comfortable, do watch these lectures once, twice. If you are an undergrad guy and if you have missed this +1, +2, but from the next lecture onwards, we'll learn how to manipulate these things, how to do different things with these functions. Okay, I'll stop the recording over here. If you guys have any questions, I'll be ready to take them.